Okay guys, this is Miss Campbell. I'm going to do example number 4 in your notes. Okay, so one thing to remember, just make this a note, a side note in your notes. If you ever have something that's like the cubed root of x, that is the same thing as if I wrote x to the 1/3 power, like x to the 1 over 3. Another example you'll probably see in your homework is if it's just like a regular square root. Now, if you have just a square root, that's the same thing as if there's an imaginary 2 out there. You know, because if you square something, that means like, you know, it'll be x to the 2nd power. So that's why a square root, it's an imaginary 2 right there. So if you were to rewrite that, it would be x to the 1 over 2. That's how several of the problems are going to be on your homework. Okay, so number 4. I'm going to go ahead and just rewrite this using what I just told you. So I'm going to write that as log base 7 of z to the 2nd power and then x to the 1/3 power. So from here I can look at this and say, okay, the z and the x are being multiplied by each other. So to expand them, I will use addition. So that will be log base 7 of z squared plus log base 7 of x to the 1/3. Now, the last step that you always do when expanding is to look at your exponents. Both of these have exponents. I'm going to need to move those out to the front. So this will become 2 log base 7 of z plus 1/3 log base 7 of x. And that will be your final answer there. Okay, I'm also going to do some problems that were in the homework. So what I just showed you in that last part, that is exactly the same as how you would do like number 1, 4, 6, and 10. So you've got those covered. Now up here on number 2, do you notice how my 8, my 11, and my 5 are all under the square root? This means that the square root applies to all of them. So I could rewrite this as log, and remember, if there's not a number right there, it's implied that it's a 10. So it's like log base 10 of, it's like the square root of 8 times square root of 11 times the square root of 5. So from here, I'm going to go ahead and rewrite this again by using what I just told you about this property. How if it's under a square root, that's the same thing as saying that number to the 1/2 power. So this is like saying log base 10, let me put parentheses, of 8 to the 1/2 times 11 to the 1/2 times 5 to the 1/2. Okay, so from there we can see very clearly, okay, these things are being multiplied, so I will expand by using addition. So that's log base 10 of 8 to the 1/2 plus log base 10 of 11 to the 1/2 plus log base 10 of 5 to the 1/2. So, like I said, whenever you're expanding, your last step is dealing with those exponents and moving them out front. So, my final answer, it's going to be 1/2 log base 10 of 8 plus 1/2 log base 10 of 11 plus 1/2 log base 10 of 5. So that would be my final answer right there. Okay, just to go over some distributing rules to remember. Let's look at number 5. So, I have a 3, that looks a little bit blurry. Okay, I've got a 3 up here in the exponent. So remember, that 3 has to distribute to both the x to the 5th and to the y in the denominator. Let me try to focus that. That might be a little better. Okay, so I'm going to rewrite that as log base 4 of x to the 15, because that's 5 times 3, over y to the 3rd, because that's like 1 times 3. Okay, so from here I can see that this is division, and so the way to expand division is by using subtraction. So that will be log base 4 of x to the 15 minus log base 4 of y cubed. Now, once again, our last step is going to be dealing with our exponents. So, both of those have exponents. I'm going to move them out. So I've got 15 log base 4 of x minus 3 log base 4 of y. And that would be our final answer right there. Okay, let's go to the back. Okay, these are condensing, so we're literally doing the opposite of what we just did. It's like, let's look at number 12. So, whenever you're expanding, the last step is to deal with the exponents. But when you condense, it's the first step that you do. So, I'm looking at all of these numbers to see, okay, is there any number that needs to go into an exponent? There's not one here, not one here, but right here, do you see I have that 4? That means that will go up into the exponent spot. So what I'm going to do, just so I don't have to rewrite that, I'm just going to mark that out, and I'm going to put it up here. So now I can clearly see the 3 things that I have. And they're being added together, which means I'll condense it by using multiplication. So I'll have log base 3 of a, b, c to the 4th power. And that is all there is to that one. Like number 14, it'll be very similar, but notice the key difference is that this has subtraction, so you already know you're going to have to use division. Okay, but let's look at number 13. Okay, so this one looks very weird, and like you don't know what to do with the denominator. But is this not the same thing as if I had written 1/2 log base 9 of a? That's the same thing. And when I look at this, I notice out front there's a 1/2, which means that is actually what used to be up in the exponent above the a. Because whenever I expanded it, I had a 1/2 power here, I moved it out front, and then I just kind of rewrote it like that. So, keeping that in mind, I can rewrite this now. So log base 9 of c plus log base 9 of a to the 1/2. There we go. That got rid of my number out front. That gave me that fraction. Plus log base 9 of b to the 1/2. So now I can combine things. They're being added, which means I'll condense by using multiplication. So I've got log base 9 of c, then a to the 1/2, b to the 1/2. And technically you could leave it there, but it's more correct to understand if you have something raised to the 1/2 power, like we said in our notes, something raised to the 1/2 means it was actually under a square root. So I'm going to rewrite this as log base 9 of c square root of a and square root of b. Now from there, if you wanted to, you could rewrite that. You could combine the a and b since they're both under a square. You could put log base 9 of c square root of ab. It doesn't matter, but this answer is perfectly fine. Okay, I hope that helped answer some of those questions on the notes and on the practice.